Hi, welcome to lesson 61, which is remaining fractions and two-step equations. First off, we are going to do a pizza equation when we're talking about fractions. Let's see, let me pull this down a little. When we have to think of a fraction as, when we have a fraction, our denominator shows the whole and how many parts it's cut into. So we have to look at, when we have some, we also have some other. Let me show you a picture of what I mean. Here's an example of the pizza that the kids ate. And it was cut into 8 equal slices. So I'm going to cut this into 8 as equal as possible slices. And it says, after Willis, Hunter, and Suletta took a slice, what fraction of the pizza was left? So we're taking this out. They ate this, and they ate this. So what was left? We know that our denominator is 8, and they've taken 3 pieces out. So we have 3 out, and we have 1, 2, 3, 4, 5. So we had a whole pizza, we subtracted 3/8, and what we have left over is 5/8 of a pizza. Now, one thing that you will note, when everything has to come up with, when we're dealing with a whole, everything needs to come up to 8/8. And so if they took 1 pizza away, they would have 7/8 left. If they took 2 pieces away, 2/8, they would be left with 6/8. If they took 3/8 of a pizza left, if they took out 3/8, they would have 5/8, which is what our 5/8, which is what our problem was. If they took 4/8, they would have 4/8. Now, let's look at that. We have these two amounts, and they are equal. That tells me that this is another way. This is the half. So they're in halves. Now, if they take 5/8 of a pizza, they will have 3/8 left. If they have 6/8 of a pizza, see, if they have 6/8 of a pizza, they will not have 6/8 left. They will have 2/8 left. If they have 7/8 of a pizza, there will be 1/8 left. And if they have 8/8 of a pizza, they will have 0. No pizza left. And so you can see how this kind of shifts as more is taken, there's less that's there. Here's another example. The two-fifths of the crowd cheered. What fraction did not cheer? So we're going to write this down. 2/5, and because of our denominator, we know that we can divide this up into 5 parts. Here you guys go. This is going to be 5 equal parts. Fingers crossed here. 1, 2, 3. So 5 parts. 1, 2, 3, 4, 5. So if 2/5 of the crowd cheered, it's these guys. What number did not cheer? What amount did not cheer? 3/5. And we could do this, and we could draw this, but we could also say 5/5 minus 2/5. Note that our denominator stays the same, but our top is what we're subtracting. So 5 minus 2 is 3. That's a little side note there. Next, we need to talk about two-step equations. Love a good two-step equation. Here is our problem. 2 times something, and when you see a number and a variable together, that gives you the clue. You need to multiply those two together. So 2 multiplied by our variable n equals 7, our unknown equals 7 plus 5. So our first thing we have to ask ourselves is 2 times what number equals 7 plus 5? And since we don't know yet, we need to first work on this side. So 2 times our number, we add 7 plus 5, and that equals 12. And then we have to ask ourselves, 2 times something equals 12. Because we know our multiplication facts, we go, oh, of course, this n equals 6. We know that 2 times 6 will equal 12. Hallelujah. Our next problem is they want you to find m in the equation. 3 times m equals 4 times 6. Let's begin. Our first step is to work with what we know. So 3 times something equals 4 times 6. And so we know 4 times 6 is 24. Yay. Now, 3 times something equals 24. I know my math facts. Thank goodness. I know that 3 times 8 equals 24. So our answer is 8. And we can check it if we wanted. Let's say 3 times 8 equals 4 times, it would help if Mrs. Daw wrote this correctly, 4 times 6. And guess what? 24 equals 24. Fabulous. Let's mess around some more, work some more in the practice set. I'll see you there.